From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Way easier to print a part than it is to actually sell it, right? To actually be able to provide the pedigree along with the part that enables people to feel comfortable that it was made with the right pedigree and the degree of quality is the challenge in AM. And I think that's not necessarily just medical, that's all industries. I'd even say it's even harder in industries like aerospace.
That was Ryan Kircher. Ryan is a Senior Additive Manufacturing Engineer at RMS. Ryan is an experienced metallurgist with a demonstrated history of working in the additive manufacturing industry. He has had extensive career working in the 3D printing sector with stints at Lockheed Martin, medical modeling, 3D systems, his own consulting company he started, and now RMS. Ryan has a ton of shop floor experience developing medical device solutions and is certainly one of the most knowledgeable experts out there on building and qualifying medical devices using metal additive manufacturing. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcast, including Spotify, Apple, Amazon, or Stitcher.
Excited to have Ryan on the show today. I think we're going to cover a lot of ground here, and especially a lot in the medical space. We haven't done too many medical related podcasts, which is always good to add to the repertoire of conversation. So, Ryan, thank you for joining us. I like to start all these podcasts out with some context of who we're talking to. So, by doing that, I like to start at the very beginning. So, where'd you grow up? Where were you born? Kind of what kind of got you kind of early days interested in kind of science, engineering, manufacturing, things like that?
Oh, glad to be here. Thanks for having me on. I'm looking forward to a good discussion. Let's see. I was born in Sturgis, South Dakota. It's a small town. It's most famous for the motorcycle rally that happens in the middle of summer. And I was actually born right when that motorcycle rally was happening. So it was like me and a bunch of bikers in the hospital at the time.
Nice.
My parents moved to Colorado when I was about 3, and I grew up in the Front Range of Colorado.
So what does that mean?
I grew up in Boulder, Colorado, like Lafayette, Louisville, where all those really close to where those fires occurred a couple months ago. So I grew up there, and my stepfather was an engineer, and I knew kind of pretty early on in my life that I wanted to be an engineer, just because those were the kind of things that interested me, science and math and chemistry, all those kinds of things. I actually really liked chemistry. Applied to a handful of schools, including the Colorado School of Mines and CU, but CU was so close to home that I wanted to get a little bit away, so I ended up going to the Colorado School of Mines in Golden. And it's a pretty interesting school. They hand you your schedule for the first 2 or 3 semesters you're there. Every single student takes the same classes. Because everyone there is pretty much going to be an engineer or a computer scientist. I think maybe they have an economics degree now too. But essentially everyone there is going to be an engineer. I wanted to be a chemical engineer, and that's what I did for a while. And one of my key core classes that I had to take was a materials class. And we, we're throwing things in furnaces, breaking things, and looking under things in microscopes. And all my chemical engineering classes were just a bunch of like calculations and computer programming and stuff, and nothing really tangible. So I made the decision after about 2 years to switch to a degree in metallurgical engineering. At the time, I didn't even know how to spell metallurgical engineering. My advisor gave me a hard time. But I don't know, 5 years after that, I had a master's degree in metallurgical engineering.
Is it a big program?
What's that?
Was it a big program?
No, not really. I think my classmates, less than 20, 15 of us maybe. Pretty small, yeah. Colorado School of Mines was pretty well known for their steel research and stuff like that. So a lot of our education was, steel based, which makes sense because, it's the most prominent metal around, right? So, and I did a master's degree there, looking at the effects of strain rate and stuff like that on some new novel materials. And stuff like that.
And did you know at that time when you were looking at mean, you had an interest in terms of like, the metallurgy and material side, but did you have kind of a career path in mind, or were you seeing kind of other people in the class, like the upperclassmen, or going into certain jobs that seemed appealing?
That's a good question. Not really. I really liked what I was doing. Like I loved the subject matter, but I didn't really think that forward into what I would be doing as a career, and more importantly, where, right? So once my master's degree was kind of wrapping up, I started doing some job interviews and looking for jobs. And I don't want to, you're from Chicago, but like almost all those jobs are in the Midwest, right? It's like either Pittsburgh or kind of in that steel belt, like south of Chicago, right? That's where all of the job openings and stuff were. So I was interviewing, or like mini steel mills. I was interviewing for some steel mill positions. A lot of those are along the Mississippi River because that's where they bring in a lot of the scrap steel to recycle. So a lot of them are based literally on the river for transportation reasons. So yeah, I love Colorado, and all of a sudden I was faced with a reality of really having to leave and go somewhere
Gary and
I was really excited about. Yeah, I ended up in Michigan, in the south eastern part of Michigan, working for a automotive manufacturing plant, working in their heat treating facility, heat treating gears and bearings and stuff. That was my first job out of school.
And so what was that like?
It was a unionized facility, so that was a learning experience, right? Being a 22-year-old guy, having to kind of deal with a lot of politics and stuff like that was really challenging. The job itself was really cool. It was really hard because we were in charge of like maintaining furnaces and doing those types of things. And that facility only shuts down twice a year, once over the 4th of July weekend and once over the Christmas break. So I was forced to stay there during those times too. So it was kind of hard, being away from home for the holidays and stuff. But the projects we worked on over those times are really cool, like going inside the furnaces and putting in new pieces of equipment and stuff like that. So covered in soot and stuff like that was, it was fun and interesting. I liked it a lot.
And it seems to me, I mean, this may be my stereotypes, but like metallurgy and kind of welding engineers, material science, like it seems like the people that I know that have that degree, like tend to really get their hands dirty, and literally in this case of like having a lot of, like you have to kind of touch and feel and see things to kind of get a good sense of how your job's doing or kind of what you're doing with your job. Yeah,
absolutely. It's all, I mean, even in college, always looking at stuff on microscopes, mounting, polishing samples, putting things in furnaces. Yeah, it's a very hands-on-ish type profession, right? And then also like trying to visualize things, a lot of like thinking about like microstructures, crystal structures and things like that. You have to kind of, be able to visualize a lot of things and kind of imagine what things are like what's happening on like a microscopic level and stuff like that in your head. But yeah, it is a lot of hands-on type stuff for sure.
And so as your kind of career transitioned, kind of you start out in automotive, was it your intention to kind of stay in more industry driven type of work, or like were you interested in kind of as your next step, like a specific topic area or type of technology? What kind of happened after that first job?
Well, I loved the job in Michigan, but I went and saw a therapist there, like in the middle of the winter once, and at the end they're like, I think you have seasonal, I can't remember what SADS or whatever
seasonal affective disorder.
Yeah, and they're like, you should go get, take vitamin D and get some UV lights and things like that. And like before I even left that session with the therapist, I was like, I think what I'm going to do is move back to Colorado. Right. So ultimately, geography is what brought me back to Colorado. I had a really good friend that I went to school with who was a mechanical engineer who got involved with a company called Medical Modeling, which was one of the front runners as far as using 3D printing, rapid prototyping, what we now call additive manufacturing, for the medical device industry. And he was working lot on the software side and some polymer printing. And he's like, why don't you just come? I think I can get you a job working for this company. And I was like, I just spent 6 or 7 years studying metallurgy. I really want to like apply, my education to my career. And it's just, I'd love to come work for a company like that, but I feel like I'd be throwing away my education. And then that went on for about a year or so. And then he called me up one day. He's like, hey, we're buying this metal printer. And I was like, what? He's like, yeah, we're going to 3D print in metals. And I was like, okay, sure, whatever. I mean, this was 2004. So I didn't really, believe him. And he shipped me a chunk of titanium off of a RCAM EBM printer. And I used my company resources at the lab to cut it up and look at the microstructure and everything. And lo and behold, it was like real solid metal. I was pretty surprised. That was, I don't know, like early November-ish. I came back and interviewed over Thanksgiving break, and then went back and put my resignation in and was back in Colorado working for medical modeling by Christmas time.
And so what was your job role, or what was your function? Were you running the machines? Were you kind of doing analysis, all of the above?
All of the above, right? Trying to figure out what to do with it, right? So this was really, really early stages. I think that was the second or third EBM system installed in the US. There was a company out on the West Coast that bought some systems to start printing in aerospace called CalRAM. And then there was the NC State. NC State had a RCAM system or two. And so I said that was it, right? So we were just trying to figure out what kind of properties we could get from the material, right? And the owner of medical modeling is a really bright guy, but he wasn't a metallurgist and didn't really understand. I don't even know if he knew what yield strength was, right? Like, or an ASTM standard was. So really early stages, I was, we were just trying to figure out what are we trying to print? Like what material properties do we want to achieve, and can we achieve those? And how do we, prove to the medical device community that we can actually achieve these? So that was kind of the early stages, right? And then even while that was going on, we were trying to identify how we could actually use this printer to make products that people would want to buy, right? So, and medical modeling up until the time they bought the RCAM system was a very patient-matched, custom, anatomical-based company, right? We were getting CT data from hospitals or labs or whatever, and printing things that match patients' geometry. And I think, initially we were like, we should use the metal printer to print patient-matched implants and things like that. And we quickly kind of found that that's really hard to do, right? Especially with the metal printers back then, they just weren't reliable, right? Nobody knew how to support parts right, knew how to be successful printing something the first time. So if you wanted to print a patient-matched implant, it might take you 4 or 5 times to get it right. And machines don't work for that, right? And someone's waiting for an implant, right? So we quickly kind of found that like off-the-shelf implants made a lot more sense. So we identified a couple key customers that were willing to work with us to develop their products and the quality control system around what it would actually take to make and sell and implant parts coming off of those RCAM systems.
Right, because in many cases, the quality control, quality system around the printer is just as, it's critical.
Way more important.
And a lot more detailed.
Right? Yeah, way easier to print a part than it is to actually sell it, right? To actually be able to provide the pedigree along with the part that enables people to feel comfortable that it was made with the right pedigree and the degree of quality is the challenge in AM. And I think that's not necessarily just medical, that's all industries. I'd even say it's even harder in industries like aerospace and stuff like that.
So what was like when they first got the machine in, someone had to write a PO for $1 million or whatever a RCAM system cost at the time. Like how did it get over that hump? Was that like the owner's like, hey, I see the vision and like, this is going to be good and I'll get Ryan to work his magic and figure it out? What was the?
Well, so it was purchased before I got there. And yeah, I would say that Andy Christensen, he was the president of it was a private company too, right? So it was this, he went and made that decision on his own to invest in it. And I'm not sure if he convinced some people to help fund it or what, but he had the vision. Yeah, I mean, medical modeling has kind of had that history before the metal printing too, right? Like the president was working for a company that made CMJ implants and spun medical modeling off from that company because he saw the potential for using 3D printing to help that type of industry, right? So it just seemed like the logical step for him, I think. I'd be curious really to ask him if he knew it was going to be as challenging as it was, right? I think the challenge for doing anatomical models and polymers was much simpler than implantable medical devices, right? Like there was a lot more hurdles for us to have to go through for sure.
And talking from a metallurgy perspective, what were some of the challenges early on in the technology that you saw that you kind of had to overcome with kind of reliability or different steps of the process that you had to kind of add into kind of when it first came out of the machine?
Yeah, I think one of the challenges that we had is, these were some of the first machines out there. So you needed to draw conclusions, right? You needed to start figuring out, if I did this, it results in this, process inputs equals process outputs. You had to start doing that. And you assume when you do those activities that you understand all the process inputs, right? And these outputs, right? So you do these studies, but there were process inputs that we didn't know were happening, right? So things were changing without our intention, and they were skewing the outputs, and so it just learning what those were, right? Because at that point nobody really knew what the key variables to metal additive manufacturing were. We had our intuition and our thoughts on things that were important. And some of those are totally wrong, right? Like we thought, that they're just, you go look at, there's a guidance document that the FDA wrote about things to consider for clearing a medical device through AM. And it talks about all these process variables. And a lot of those aren't, for certain processes, aren't key process variables. They don't actually influence the properties of the parts at all. Things like orientation, location, things like that, depending on what properties you're actually looking at, aren't as important as people think they might be. But other things are really important that we didn't really think about, One of the bigger challenges with titanium metal printing is controlling the chemical composition of the powder, right? We early on didn't understand how much that composition would change as we reused powder. And we didn't have the infrastructure in the way of analyzing that powder before we printed parts, right? So we were waiting. We print parts, send them out for chemical analysis, and then we'd get the results back, and they'd be outside of the specification, and we'd be like, crap, what did we do wrong? And it was because the chemical composition of that powder was changing. Eventually I had to go to my boss and say, we can't just keep building parts and crossing our fingers and hoping they come back with passing chemical composition. We have to know ahead of time that the powder we're actually using is conforming to the standards. Otherwise, we're printing bad parts and not even knowing it, right? So that we had to, have those kind of analysis equipment and stuff available was important.
And that's such a rabbit hole of material and powder management, right? Like in these systems, it's expensive powder, right? Like that, it is. And you want to minimize, you want to use as much of it as you can eventually, to make a business model kind of go forward, right? You don't want to waste a whole lot of it. And so you have the option of blending, but then there's blending / mixing different lots. And did this particle, what exactly did it see throughout the entire process? And so, especially with some of the newer systems too, whether they're doing internal sieving and mixing, it's, you could spend a 5-hour discussion on how to
and the industry's still really bad at it, in my opinion, right? But I mean, even within a system, you know, there's certain printers that recycle the powder while it's printing, right? There's others that you know, sieve it and stuff outside of the system. You know, certain situations where, you know, really high-end applications where you're not allowed to reuse powder at all. And the industry still doesn't have really good terminology and nomenclatures around communicating that. I mean, even just saying like this powder's been reused 5 or 6 times, like, to me, that word reused doesn't really mean much, because a particular powder particle may have just, you know, gotten brushed into the overflow during build 1, right? And then build number 2, maybe it ended up right next to where you were printing a part. And those are 2 completely different experiences that particular powder particle saw, right? So yeah, it's a really complicated thing. And I don't think the industry's really wrapped their head around or figured out a good way of tracking and communicating it yet.
So after, or like you started with kind of with the RCAM system and E-beam with your additive career, kind of where did it go from there?
So I spent 7 years at Medical Modeling, building up that, you know, working with other people to build up that titanium medical device printing business. And I really enjoyed that time there, you know, figuring out all these problems, finding the right applications, putting all that infrastructure and stuff together. And then once it was done, you know, it's like, okay, now let's hire some more people. Let's bring on some more machines. Ryan, you're keep managing and overseeing that stuff. And it turned into a completely different challenge, right? Instead of trying to, you know, figure out this technical issue, how to control oxygen content or monitor it, it turned into making sure that we delivered, you know, this number of hip cups by the date we promised, right? And trying to figure out how to schedule the machines, how to, you know, give lead times to our customers correctly, and then managing people, right? Making sure such and such guy came in and flipped that machine right and communicate. And I mean, be blatantly honest, I didn't like that stuff. I'm not good at it, right? So I got to this weird spot at Medical Modeling where I was like, man, we built this awesome thing, but man, I don't want to manage it. So that led to me leaving and going to work at Lockheed Martin. They have a space systems company campus in southwestern Denver, and kind of went and did the same thing there for a couple of years. Kind of helped them establish a lab that was using EBM technologies to print titanium. And then also there I worked with a lot of FDM polymer printers as well, helping them print shop tools and all kinds of things.
Awesome. So in some way, I think you mentioned this before, like very rigorous in terms of quality management. Ultimately, when you get to the production level, I don't know if were you doing more R&D, kind of getting these printers ready for production path, or was it all kind of production when you started?
Oh no, it wasn't production at all. We were using a bunch of funding that Lockheed had to establish an allowables database, right? So when an engineer wants to go and design a part with additive titanium, he needs to understand what the properties are, right? So we developed that database where he could go in and look at what the design properties he needs to assume when designing his part work. And that took almost the entire time I was there. That's pretty much what we focused on. That and trying to, again, identify some of the right applications for the process. A lot of education of working with designers to try to help them wrap their heads around design for additive. Working a lot with the machine shop to try to figure out how to take an additive part and do some machining operations to it and end up with the right product at the end, which is not easy either, right? It's a lot easier to start with a block of material and whittle it away to get what you want, than take this part that already has a bunch of organic surfaces and things like that, and figure out how to fixture it in a CNC mill and locate on it and make sure you put those holes or whatever you're going to do in the CNC mill in the right spot. That's really, really challenging. Luckily, Lockheed Martin has a lot of really experienced machinists, and a lot of them have been there forever. And a lot of them worked back in the day when they were using a lot of castings. and stuff like that. So that mentality and the way that you would, create a drawing for a casting and then machine a casting. I learned a lot from those guys about like that kind of stuff, right? Because the way that you would have to machine a casting and the way you machine a additive part aren't exactly the same, but a lot more similar than just starting off with like a block of raw material.
This is probably a loaded question because I live it every day, but like when your experience with the data allowables challenge and kind of generating that database of information and then communicating it to a team. With a lot of what we do I'm trying to think about that for some of the software we do, but kind of what were some of the challenges that you saw in trying to kind of, it's one thing to, like, I always get frustrated in the additive world where you get a data sheet from a material supplier or of an OEM, and it's like, okay, here's tensile, and you get like
those could just
plus or
those
minus.
Are just those go in the trash. Those don't actually have any like technical merit to them.
So So were you going?
I haven't
like
gone through my entire career, but I helped develop those in the past too, right? I mean, they just don't. You don't know how those parts were made, right? I think that's the biggest challenge. That was still 10 years ago when I was working at Lockheed Martin, and knowing that the parts were made. I don't think anyone knew how to control how to make the parts, if that makes sense. So, and there was a lot of these weird competitive type IP things going on too, where, people were claiming that, their system or, their material would result in properties that were different than this system, and it had less to do with the raw materials and the systems, more about like how people were actually running them. Right. So, and nobody knew how to write work instructions and manufacturing plans and stuff in a way that prevent human error and those types of things entering into the equation. Right. So knowing that you have an apples to apples comparison between two data sets that were made by different people was really hard. And I think it is still kind of hard. Right.
Yeah, I think from all the conversations I've had, it's like when you get data back in that situation, like you send data out for inspection or something like that. Like I was in a meeting the other day where you sent out data to a third party vendor who does tensile and all the characterization. You get the data back and then you sit in a meeting to go over it, but 95% of the meeting is, hey, what parameters was that set at? What were all the other stuff that's not recorded and just that tensile.
Or people don't even want to share, right? Like there's still metal system OEMs out there who won't give you their settings, right? Yeah. They're like, we have release settings. You can go and make, here's the Ti 6.4 settings for our printer. We promise you it'll make good material. But like as a development engineer, you have to know what those values are, right? And some of them don't even share them today. I mean, 10 years ago, nobody did. So I think it was a big challenge because you never really could trust any of the data you saw, I guess, to be able to.
Oh, so Lockheed kind of into aerospace, kind of what was next in the career path?
I enjoyed my time at Lockheed. But man, aerospace is I'm not a very patient person, and the aerospace industry is very slow moving. So while I was learning how to work in the aerospace industry, medical modeling was purchased by 3D Systems. And they invested heavily in a state-of-the-art facility in the western side of Denver, in Littleton, Colorado, for a giant medical device manufacturing facility. And they essentially lured me back. So I joined 3D Systems. Basically the same people I worked with at medical modeling, but now it was 3D Systems. And I spent 3 or 4 years there. While I was there, I created what I think is now called the AIG. At the time, we called it the CIC, Customer Innovation Center, a group of engineers and systems to help customers kind of just figure out applications, right? So a customer would come to us and like, wow, we think we want to kind of print this part. I think this is what it should look like. We'd help them design it, help them develop the right parameters and stuff. ultimately, trying to grow 3D Systems metal printing.
And so what was it like working for an OEM?
It's interesting. I mean, I don't think it's any surprises, and I'm sure it's like that at a lot of companies, right? Like, I was an engineer. I was, overseeing a group of engineers, but ultimately our purpose was to help 3D Systems sell printers. And we had a bunch of sales guys out there selling printers, and so there was a lot of heated discussions about whether our printers could actually do what the sales guys wanted them to do, right? And I'm sure that happens in every industry, not just AM or 3D Systems, right? But you learn a lot. You learn a lot about, when you're an engineer, you can kind of just focus on the practical parts, but like thinking about it from the other side of, the economics and things like that, you learn a lot about, not just whether this is technically possible, but whether it makes sense to do it all, right? From a financial standpoint, things like that. So yeah, it was a really interesting learning experience. I got a lot of exposure to a lot of different applications there and a lot of different materials and stuff that I hadn't previously been involved with, which was
Were
great.
you still mainly working on kind of medical aerospace, or would more broad kind of the entire like
metal
spectrum of?
It was metal, so it was all metal focused, right? So I mean, and that particular facility was really good at medical devices, so there was a lot of that, but then a lot of aerospace, defense. I kind of think space exploration is a little bit different than aerospace. A lot of that, and then oil and gas, some other things. 3D Systems had a printer that was really good at printing some like tire molds and stuff like that, some more industrial applications. A lot of, and I also supported our Asian team and a lot of conformal cooling, injection molding tools, and those types of applications too, which are pretty cool.
Nice. And so kind of I think it's the last step, or like the kind of next stop. So RMS. So you want to talk a little bit more about kind of what you're doing now?
Yeah, I did a consulting gig.
Okay, that's right.
But RMS was one of my customers when I was at 3D Systems, and then they were my first customer when I was a consultant. So one day I was talking with the operation manager over there about potential projects that they might need my help with, and we came up with such a long list in 45 minutes. At the end of the conversation, he was like, why don't you just come work for us? And I've always really enjoyed working with them. It's a really cool company. They've been around for a really long time, and they are really excellent at subtractive and conventional manufacturing, and got involved with additive 5 or 6 years ago. So I've always really appreciated their perspective on manufacturing, because they've been manufacturing medical devices, for 25, 30 years or something, and just now are learning additive. So they have a different perspective than I've ever had in the industry, where it was, hey, we're doing additive, let's print medical devices, right? So their perspective on how to machine parts, quality control, all those types of things, how to scale things, was just a lot different than the mentality that I had typically seen in additive manufacturing.
So what was the biggest difference?
Like if you're a company and you have a 3D metal printer, right? Like medical modeling, we had our RCAMs, we had some basic blasting cabinets and some basic finishing equipment, but we didn't have any cleaning, passivation, no CNC milling, none of that stuff, right? And you look at the actual workflow for an additively manufactured, they call it additively manufactured spinal cage. The additive manufacturing part happens in the first day or two of a 6-week cycle, right? Like we print the part, then there's wire EDMing, there's blasting it to get rid of the loose powder. There's almost always some sort of heat treatment. Then there's machining, a cleaning step here and there, passivating, laser marking, a whole bunch of steps, right? So they had all of that knowledge, and then they brought additive in as a tool, as another step, right? Where if you're a company that just does additive, you want to try to maximize the value of what you can offer. So you're like, oh, we can print that. We can print that. So instead of like designing a part like holistically, trying to take advantage of all the tools you have available to get you the best part for like the lowest cost, which is RMS's approach, you would kind of approach it like, how can I get the most value from additive out of this, right? So it's just been kind of a learning experience. I've only been there for about a year, but like instead of sitting there going, oh, I think we might be able to print this threaded feature if we orient it in this direction and stuff like that, and making compromises, you're just like, no big deal. We'll machine that thread, right? So at the end of the day, you end up with a much better product, I think, when you take in consideration all of the manufacturing steps from the beginning.
Yeah, it's a really interesting perspective. I like that. I've not thought about it in that context where you kind of think about it in the grand scheme of things, how long additive is actually in a process step for something like medical device, or even really most other kind of metal printing steps, right? You've got a long set of checklists and steps that you have to get to.
When I was at Lockheed Martin, we did a spaghetti diagram. You can go and look up what that is. It's a thought exercise of like kind of following a part through its life cycle and all the different handoffs and times, to try to understand the delivery time, because, a lot of upper management gets sold on additive manufacturing as being this really fast, agile way of making things, right? So when our upper management found out that we were telling people it was going to take 3 months for them to get a titanium bracket that they could use, people were like, hey, what's going on? Why? I bought this system thinking that we could do that in like 3 days. Why is it taking 3 months? And we went through that spaghetti diagram exercise, and I think there was like 200 handoffs or something that had to happen, right? And a handoff is when, one person has, when a certain task needs to happen, be conducted by a certain person. But it's all these little things, right? Like issuing out material, pushing play on the printer, getting the design ready, receiving the powder. Even once the part's printed, it's, getting it to the shipping department so it can get heat treated, getting it back, getting it inspected, pulling tensile bars, all those post processes I was talking about, non-destructive testing, all kinds of things, right? So yeah, the additive part was only a day or two, but the entire cycle is much, much longer.
So I just have kind of two final questions before we wrap up here. So kind of first one is kind of, what are you excited about kind of looking forward in kind of February 2022? Like, are there any things on your radar? I mean, professionally, kind of what you're working on, or even outside that kind of grand scheme of things that you're excited about and kind of you're putting a lot of effort into?
We're installing a couple newer different systems at RMS. So we have a bank of printers printing titanium, but I've convinced my management department to start printing some stainless steel alloys. One of them's kind of a newer alloy that hasn't really been out on the market yet. So I'm really looking forward to putting on my metallurgy hat and really diving into figuring out how to all the pitfalls of printing that particular material. I have no idea what chemical elements are going to change as we use powder, all that kind of stuff. There's so much to learn. So I'm really excited about that. And we're also installing a system that has multiple lasers. So that adds a whole bunch of other challenges to a process that we have just now started figuring out. So I'm excited about those two challenges from a technical standpoint. It's not February, but March of 2022. I'm excited. I'm the meeting secretary for ASTM F42, which is the Additive Manufacturing Committee. And we're holding that meeting in Golden, Colorado. So at my old alma mater at Colorado. I've been coordinating that meeting, so I'm really looking forward to seeing people I haven't seen in like 2 or 3 years because of the pandemic at that ASTM meeting. So.
Is that open to the public?
What's that?
Is that open to the public or any?
Yeah, pretty much, right? You got to pre-register. I think, I don't want to get in trouble, but I think you maybe have to pay like a nominal fee, like $75 if you want to have a membership that allows you to vote. Otherwise, I think you can kind of go to the meeting as long as you're pre-registered. at no cost. Yeah.
And final question, kind of as you kind of reflect on your career, and thank you for kind of sharing kind of your various steps and experience here, but what advice might you give to someone maybe just starting their journey in manufacturing, additive manufacturing engineering?
Ooh, that's a loaded question. I guess the biggest piece of advice I'd give them is don't be afraid to, don't settle. Like if you don't particularly, additive manufacturing and manufacturing in general is a very large field. So like if you don't like what you're doing within manufacturing, maybe, pivot and do something else, right? Like some people really like quality, right? Like to write process validations and stuff like that. Other people like to design things, right? So when you look at additive manufacturing and manufacturing in general, there's all these different types of jobs within that industry that are significantly different than each other, than the other ones. And so, and even, I mean, I've been on a lot of the sides of the table, right? Like I was working for a company that was using printers. And then, I found myself working for a company that was selling printers. And those are completely different things too. And on paper, they might look really similar, but they, look at it from different perspectives can be kind of totally different. So that'd be my advice. I mean, especially in the climate as it is right now, I mean, this industry is hurting for qualified engineers. It's not hard to find a new job. So if you're not happy in the one you're doing, and that'd be my one piece of advice, find a job you're happy doing, because there's a lot of opportunities out there.
Awesome. Well, thank you for sharing your story today, Ryan. I really appreciate it, and look forward to seeing you in person soon.
Yep. See you, Mike.